Greetings once again. This is going to be a video on a project that I'm working on consisting of two cameras that I bought. I bought some security cameras. They're ultra cheap, and that's going to be a whole different discussion right there. But I did buy some outdoor weatherproof cameras that I could grab some images day and or night. And this is going to be an introductory video on those cameras. So there's a lot of things that we can learn just from these particular setups, and I'm going to be making some videos on them. I'm already going to be touching on one or two of these in this video, particularly the positioning of the camera and trying to find the best alignment. The other thing that I want to do is use this as an opportunity to see if we can do a little bit of sleuthing, that if we have one particular known, that we can then start to discover a few other things. And then once we have those other things, then we can discover even more things. And that's going to be a whole different set of discussions right there. Just to give you a preview of what that's going to be, I've got this camera pointing in some relatively unknown direction. So for example, this camera here is facing south. So is this the 180th azimuth, or is this the 180th azimuth? So that's one thing. The next thing is just exactly where is the camera rotated this way. It's not, I can tell you right now, it's not horizontal. It's not pointing perfectly straight. And there's a reason for that I'm going to cover in this video. But what is the orientation of the camera? And the other thing is, can we correct and compensate for the fisheye lens? And when I'm done, I would like to have an equation that would let me locate any object in the reference frame and be able to turn it back into a celestial coordinate with an azimuth and an altitude. So the first thing that I want to do is just give you a preview of the day. Yes, this is the day. I want to give you a preview of what can be captured in the day. So this was done on the, you can see right here, this was done on the 13th. And it covers the sun's movement across the sky. So this one here, this is the day that I did the last video concerning taking sun's measurements, taking the measurement of the shadow of the sun. As you can see, I just had to run out from time to time and make sure that I got the right timing between the clouds. So the next one that I want to show you is at night. This was later that this was the following evening. So this was actually last night. And again, there's a few clouds, but thankfully the moon is bright enough that it will peek in through the clouds most of the time. And there's a couple of things in this one that I want to point out as well. It was a bit of a discovery process. There's the stars, and you can maybe just make out a little bit of Altair, right, or the Orion's belt. So there's a couple of things that I wanted to point out. You'll notice that the time at night here, particularly if I move the mouse away, right here, you can see that the seconds are all blurred. And what I've done was I took 8 individual pictures. I've actually got 2 cameras, and I'm going to get to camera 2 in a minute. I've got 2 cameras, and what I do is I request one picture from the first camera, then the first picture from the second, then I take the second picture from the first, second from the second. So I take 8 pictures for each one by one, at night when it's low light. And then what I'll do, I have an application that takes those 8 frames and it combines them and it averages them out, and it ends up reducing the noise and bringing out the stars. So you'll see that that's why the seconds are somewhat blurred out because of that. In this particular clip, I want to show you what it looks like for an entire evening as the stars move across the sky. Hopefully this is going to come through in on YouTube. There's going to be several compression and cycles, and it might not even come through, but hopefully there's going to be just enough coming through. So this was taken on the 9th, the evening of the 9th and the 10th, and you can see the moon just kind of peeking through. And then as soon as that's done, and we're approaching the morning, you can see over here Orion in particular. Right here you can see Orion's belt, maybe a little bit. And then if I switch over to camera 2, you can see this one move like this. When I set it up initially, I pointed it a little bit too high. So for the first almost 2 weeks, I had it set up uh, a little bit higher than it should have been. This here would be closer to about 40 degrees altitude, and for almost half of the year I realized after this point here that the sun wouldn't even be visible, and that in the dead of summer it would only come up to about here. So I re I pointed the camera down slightly. You'll see the corner of the house over here, and there's a lot more of the tree here and a little bit less of the tree over here. So here's more of the tree and here's less of the tree, but when I switch over to here, I've shifted it down. I've also rotated this thing so that horizontal is kind of like this at a bit of an angle, because the thing is I don't really know how low the sun is going to go in the dead of winter or how high it's going to go in the dead of summer. So I figured if I rotate it slightly, I'll have a much wider angle. I went with a theodolite app and I used the tree as a measure to find out how much of an angle vertically I could get, and it's not quite 40 some, I think it's about 41, 42 degrees, which is not quite enough. So where this is, if it was pointing perfectly vertically, the sun would just kind of get over the edge of the frame, and in the dead of winter, it would just kind of get underneath the edge of the frame. So that's why I did that rotating thing. That's why I rotated it slightly so that I could use a slightly more diagonal reference to at least be able to capture the sun somewhere at its zenith in that particular date, any time of the year. Now these are obviously the shots taken at night, but I want to point out this star I've eventually discovered is Altair. Now this camera here for the first 2 weeks has not been repositioned, so uh, the position of the star is shifting. You can see the trees are staying where they are. And again, just like the North Star, Altair is shifting more towards the west every day. for at the same time. So it was over here, now it's over here. Here it's cloudy. Here it's slightly over here. Oops. Now it's over here. Now it's over here. And so you can see it's the same time of the night. And at some point, it kind of goes off. At this point, I've repositioned the camera and I pointed it so it's going more like this direction. So there's Altair. The first two nights I had them in this position. I couldn't see anything because it was raining. It was overcast that evening, those evenings. So here's the first night. Here's the second night. On the third evening, I decided to shift the position of the camera slightly. Pointing it up a little bit more. The first two nights I couldn't see anything, and I was wondering if I could even see any stars. So then I decided to position it slightly higher up. There's Polaris, there's CoCab. The morning after this particular night, and I was able to see these stars, I decided to reposition it slightly further away. So I mounted it on a different post on the railing of my deck and pointed it a little bit more west. Unfortunately, the parallax between the the edge of the roof and Polaris kind of made Polaris up here, and I couldn't really see it at all. I think CoCab is over here somewhere. And on top of that, I realized that there was going to be too much of the tree in the way for at least 5, 6 months. So I decided after that I left it 2 nights and then I decided to put it back to where it was before. But then I even decided to point it down and hopefully see if I could catch a few stars underneath the roof. So at this point, that's where it stayed. Now you'll see that the camera is shifting position ever so slightly. This is due to wind blowing the camera around, and also I went back and retightened the camera a few times. So the main thing that I wanted to point out specifically with this set of pictures is that if I go to August 31st, you can see Polaris is over. Well, maybe you can, maybe you can't. Well, it'll be hard to tell. But I do have the original images, and if anybody's interested, I can give them a copy. So here is Polaris up here. Here's CoCab. Now, if I switch to 5 days later, you'll see that Polaris stays in the same position, but now CoCab is not here for 12:04 a.m., but it's actually going to be over here. And this is going to be a separate thing I have to talk about. So I'm just going to switch, and you'll see that CoCab is moved down over here, and Polaris is still up here. So I'm circling right here where CoCab is, and right here where Polaris is. So 5 days later, in this picture here, everything shifted up this way about that much. But now CoCab is down over here. And if I switch back, it's over here. So it went from here. So it went from here to here in 5 days.